and in this video, I'm going to introduce you about our project, which is Multi-Agent Diagnose System. To begin with, the motivation of this project is that the current symptom checkers are single-agent medical QA system and often suffers from 1. Shallow reasoning and generic answers. 2. High susceptibility to hallucinations and bias. And 3. Inability to identify and correct diagnostic errors. And misdiagnosis happens a lot in the real life. It delays proper treatment and patients suffer because of it. There are many causes, including bad data, unclear symptoms, or just a system guessing. If AI learns from that kind of data, they will repeat the same mistakes again. So our system tries to break this cycle by using multiple agents to cross-check and reason together. Okay, so our project to address these challenges, we draw inspiration from Google's Socrates framework. We aim to build a more advanced, multi-agent medical diagnose system that introduces creative thinking, improves diagnostic accuracy, and reveals hidden misdiagnoses. By incorporating multiple agents, we promote deeper reasoning, contradiction-based validation, and more explainable outcomes, supporting real clinicians to transparent and actionable insights. So the methodology of our project, here is how our system works. We use 2 diagnosis agents powered by DeepSeek. They analyze a clinical case, generate independent diagnoses, challenge each other, and defend their claims. Then, a team of judge agents, such as GPT-4o and GPT-4 Mini in our case, evaluate each round using the critic framework, scoring the strength of reasoning. A consensus agent, also empowered by DeepSeek, summarizes the debate and proposes a final diagnosis. Finally, a mermaid agent visualizes the reasoning path and the final consensus in a flowchart for easy interpretation. So as we said before, the judge uses CRIT scores for reasoning evaluation. The critic framework including the following 4 aspects. Claim assesses how clearly the diagnosis is stated. Reasoning checks if the logic is sound and thorough. Informativeness looks at the depth of medical detail. Trustworthiness evaluates the credibility of the arguments. Each score from 0 to 1. Lower scores means the reasoning is vague, unsupported, or logically weak. This helps our system identify which side of the debate is stronger. So here is a high-level pseudocode. We apply this to every single sentence from both pro and con agents. In every round, it checks if the diagnosis is clear and if the reasoning makes sense, the explanation has useful details, and if it sounds medically trustworthy. Here is the overall workflow of our system. The user will give the input to the system, and the symptom will be distributed to both pro agent and con agent. And after they make diagnosis separately, they will run into the mutual challenge and justification process. In this round, pro agent and con agent will challenge each other and defend their claims. And after each debate, there will be an agreement check to see if they tend to make agreement. And if so, the consensus decision agent will summarize the reasoning from both agents, and then send it to the mermaid agent and to display the results. If there's no tendency to reach an agreement and the debate round is less than 3, they will run into a second round of mutual challenge and justification and to see if it can further reach an agreement. And after the round is greater than 3, we find that both agents will not provide new evidence regarding to the same statement. So if the round is greater than 3, the consensus decision agent will terminate this process and then summarize the statement from each agent and give a consensus result and send to the mermaid agent and display the result. The critic judge team will evaluate the reasoning during the mutual challenge state and to give us an overview of how the reasoning goes. So here's a demo of our magical system. As you can see, there's a case description where you input the patient symptoms and then you click run debate so that the system will take the prompts and start to debate. And the diagnosis results is the summarization and the final choice of the consensus agent. Here, it will summarize the pro-physician's strength and weakness and also con-physician's strength and weakness. After the summarization, it will give you a final decision. The pro-physician's HPV diagnosis is more reasonable, and the reason of why it chooses pro-physician. So here is the final diagnosis of the corresponding system here. And you can see we have displayed the reasoning transcript for each round. In the first round, pro agents and the con agents give their different diagnosis and their reasoning. And in each round, they will keep their suggested diagnosis with a deeper reasoning and also refutation of the opponent's diagnosis. In third round, it will continue reason and then refute each other, challenge each other. And the evaluation, we also separate into 3 rounds, evaluates the reasoning process of each agent. So there are 3 judges, and each will evaluate the reasoning process through a critic metrics, including claim reasoning, informative, and trustworthiness. And after 3 rounds, it will generate it gives you a more it will give you a high level overview of how the reasoning goes, the performance of each agents. Yeah. And finally, there will be a flowchart to visualize the thinking path of this system, starting by the symptoms, and each symptoms related to a possible diagnosis, both pro and con. And it will provide supporting evidence of both pro agents and con agents. Supporting evidence, and each supporting evidence will finally lead to a final decision. And the one that marked as green is the final decision of the symptom, which is a pro's suggestion. Yeah, and here is an overview of the data that we chose. It includes the KGO disease symptom prediction data, where we have the symptom description and also a ground truth of symptoms. And the initial prompt will be formatted as patient presents with blah 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 blah, which is the symptom description, and then determine the most likely diagnosis and explain your reasoning. Yeah. And the rest is an example I just showed you through a web front end that we implemented. And here's and let's share the final result. So after the experiment we have done, there are several key results that we found. First, improved diagnostic depth over rounds. As the number of debate rounds increased, both pro and con agents produced increasingly specific and medically detailed arguments. Their defenses incorporated more reasoning and epidemiologic context. Likewise, refutations evolved from general disagreements to targeted, comparative counterpoints. This demonstrates the effectiveness of multi-round structured prompting in encouraging deeper clinical reasoning from large language model agents. CRIT scores also increase as the debate goes deeper. Second, consensus diagnosis aligns with independent CRIT evaluation. In our tested cases, the final diagnosis selected by the consensus agents after multi-round debate matched the site that received higher average critic scores from the evaluation team of GPT-4 based judge models. This suggests that structured large language model debate, when paired with independent critic, covers totally clinical preferred answers. Third, increased diagnostic specifically after debate. The framework not only selected correct high-level diagnosis, like viral hepatitis, but often refined them into more specific details, like hepatitis B or hepatitis C, through cumulative argumentation. This refinement reflects the system's capacity to synthesize and differentiate between similar disease categories using evidence accumulation across rounds. And last, consensus agents avoid majority bias. In case where both pro and con had strong arguments, the consensus agents did not simply favor the first or more verbal side, but selected the diagnosis with better supported logic and real-world implications. To further mitigate model bias and ensure balanced evaluation, the judgment group consists of 3 independently acting large language model-based evaluators. This ensemble scoring approach reduces the influence of any single model's preference. And here is the overall results of our multi-agent system. As we can see, if we continue with our midterm project, we use the MedQA evaluation metrics to test their accuracy in answering different MedQA problems. And the Mistral 7B we use has accuracy of 34.3 accuracy, and based on the reports provided, the GPT 3.5, GPT 4 has accuracy as shown on the table, and the DeepSeek we used in our midterm has an accuracy of 82.9 accuracy. And the multi-agent debate framework increased this accuracy by about 5%, and it reaches 87.3 accuracy. So this tells us that our multi-agent debate framework supports the hypothesis that structured multi-agent deliberation can enhance diagnostic accuracy by enabling argumentation, critic evaluation, and consensus building. Compared to single-agent approaches, our method introduces explicitly reasoning dynamics, leading to more reliable predictions on complex clinical cases. And for more experiment detail and the different case study we have provided in the reports, and if you are curious, you can read it through our report. So the conclusion is that we introduce a structured framework that leverages large language models to simulate clinical diagnostic reasoning through multi-round debate between 2 specialized agents. The framework incorporates a critic-based evaluator team to assess reasoning quality at each stage, a consensus agent to summarize and decide at the final stage, and visualization tools that convert evolving reasoning paths into interpretable diagnostic flowcharts. This setup encourages progressive, comparative, creative, and evidence-based diagnostic thinking, simulating a collaborative clinical reasoning process that refines vague inputs into medically actionable conclusions. The transparent structure and scoring also support human-in-the-loop collaboration and make the framework well-suited for evaluating reasoning-capable models. Originally designed for medical diagnosis, this structured debate and consensus framework holds broad potential across domains requiring critic thinking and multi-perspective evaluation, such as simulating opposing arguments in law or replicating peer-review dynamics in scientific research. And the future research we can do is that first, we can expand the dataset scope, and second, we can integrating external knowledge sources to improve factual grounding. And that's our project. Thank you. If you want to know more about the detail of our experiment and our system, we will provide the link of our GitHub in the comments area, and you can follow that link to get more detailed understanding of our project. And the report we also share through the link. Thank you.